We are back with what I think is the last screencast here of this short molecular genetics topic. All right, that is our and this is our mutations, or what happens when the code gets messed up. All right, first thing to understand is a mutation happens to your DNA, just like a chromosomal abnormality happened to your chromosome. But if something goes wrong with the DNA, when your mRNA, the protein, the trait is going to be messed up. But it doesn't always happen that way. All right, so there are three avenues of mutations: a beneficial mutation, which is called a change in the gene sequence, which is called a missense, and that actually creates new variations of a trait, which is a good thing, especially in the evolution, which we'll get to next week. All right, harmful mutations. All right, harmful mutations, nonsense mutations, and those are the disease mutation, which change the normal function of a trait, not for the beneficial. All right, and neutral, silent mutations, which have no effect on the functioning of a specific trait or a feature. So three different areas. So we're going to really be speaking of this area here, but notice beneficial and harmful can happen in the same way. We want you to know three different kinds of mutations this year. All right, they fall under the banner of a point mutation, and that is when one base is changed. All right, so there are kinds here. One is called a substitution, which is what it is. One base gets substituted for another. An insertion, where you insert in between, changing the whole sequence, or a delete. So imagine you're all standing in a row and I take one of you out. All right, and then the whole frame comes together. It's all different than a frame shift mutation. Or if I take all 17 of you and I put someone in the middle of the two people, that's an insertion of a gene. All right, so mutation changes the alleles, changes the trait, and it's a change in the DNA. Let's take a look at a specific example here. All right, so I kind of set it up this way for you already. All right, so you have four DNA, codes for DNA, which are going to be coded onto mRNA. In a normal sense, AGC is going to give you that codon, that codon, that codon, and this codon, which is then, if you read the table, and you should, UCG hooks up with serine, CAA that is, hooks up with glutamine, GLU, AUC, AUC is one called isoleucine, so that's an iso there, and a GAA. Okay, I'll find GAA on here. Is actually not GLU, it's GLA. Sorry, GLA glutamate. I believe that's its abbreviation. So, all right, so there's glutamine and glutamate. All right, so I'm just going to take a look at CAA again one more time. So there's glutamine and there's glutamate. So there's a little difference. I may have gotten this letter wrong, but you get the picture here. So what we have here is, all right, so a base substitution occurs, again, during DNA replication, where, for instance, we'll go here, where, for instance, the T is substituted with an A, which then changes, when the protein is being made, this to a U, because A transcribes to U. Now you got to look back. Is CUA also GLU? If it is, we're in good shape here. All right, let's find CUA. But CUA does not give you, it gives you let's say that is CUA gives you LEU. We'll type that M down here. Gives you leucine. All right. So that is CUA gives you leucine. So you have just changed the entire sequence here. And I don't know what protein you've made, but you've either made a different protein or a weaker protein. It's really not a different protein. I mean non-functional protein. Notice this doesn't have the start or stop on it. We're just using this to demonstrate here. All right. So a base substitution, one more here. Let's do an insertion here. So, or deletion. Next, so let's do a deletion. It's easier to demonstrate. Delete. All right, so if we delete, all right, again, we'll put the lines in so you can see. I've also, I think, put an extra base on this one. You've got the third one, you've got the fourth one. All right. And that is a good thing. And we get the messenger RNA back down here. All right. You've got your ACG. ACG, U, capital letters. All right. UCG, you've got the one over here, right? I messed that one up, bro. So I'm not redoing this one. You know how many times I've had to redo these things, I make mistakes. But so be it. Not a big enough mistake to do this time. All right. GTT, what does that give you? That gives you CAA there. What does tag give you? Tag normally gives you AU. Excuse me. We'll get a different one here. CAA. Good. What does tag give you? Tag will give you AUC. Normally, what does CTT give you? CTT is going to give you GAA. All right, so there it is. Line up. You need to know how to do this. That's why I'm doing this verbally. Now, there would be another one here. All right, that's why I'm just putting one letter here because it's continuous. I wanted to show you the deletion. So you see it there. You look up the amino acids. What is UCG? Look it up quickly. What is UCG? UCG, someone here. All right, you know that UCG is serine. I'll go lowercase letter for this. Is serine. We'll keep that there. What is CAA? Look it up quickly on the chart. What is CAA? CAA again is GLU. What is AUC? What is AUC? AUC normally is isoleucine. Isoleucine. And what is GAA? What is GAA? In the normal sequence, it's glutamine. So GLU, glutamine. I don't know that one offhand. I'll look that one back up with the abbreviation. I know it's not GLUA. All right, so let's put the one I had before, GLA. All right, so glutamine. Now, a deletion occurs here. So we're going to delete. So back up here, and we're going to delete out. So now you see what's happened. All right, this one's okay, this one's okay, but TGC is not AUC. Right? So what is this now in the deletion? All right, you've got you don't have A at all. You've got U, excuse me, G, right? And this one has changed. This amino acid has changed. So again, here you look up what TTC would be. And I know. C, U. All right, now that means that the amino acids have changed. What is UAG? Look up UAG. I'm going to write those in. All right. UAG is a stop codon. So that, and again, that could happen in a mutation. You've just stopped it right there. Nothing else would be read. All right. So you have stop on this one for UAG. And just for looking it up sake, what is a CUU? All right, a CUU is another leucine. So you'll notice stop codons can be inferred here, and you delete one, you change the entire mRNA, you change the entire protein. Same thing as if you add one in. So an addition versus a deletion. Just a couple of examples there. All right, Screencast